Welcome to Computer Science 1, the online edition. Today we're going to go over some of the requirements for the class. From here on, there'll be no more lectures, only this stuff, virtual office hours. That means email to the TAs and to me. Programming projects are submitted electronically, and exams we'll probably do through Canvas. Today what I'd like to do is talk about Project 4 that you're currently working on. We'll talk about how to read from the data file, which many of you already know, review arrays, and then talk about the issues of standard deviation, what it is, the formula, and an algorithm for it. For Project 4, the first thing we have to worry about is how to read from the data file. The name of it is prices.txt. You can download the data file or look at it on the interactive calendar or on the syllabus. There are links for that. If you just drag through the file, copy, you can paste it into Nano, into its own file and go from there, or you can type it if you want. It's not that long. The data file contains housing prices, and we'll regard this as a sample of housing prices in a city. And we'll compute the mean of these, and we'll compute the standard deviation. Now, how to read from the data file. The first thing we should do is make sure we've included the fstream header file at the top. You'll see the include on the next block of code that comes up. And then create a input file stream variable. In file is the variable here. And then we can go ahead and read from it once we've opened it up. And you'll see in this example that we're adding the number that we read to the sum each time, so it accumulates the sum of all the values entered. If we wanted to count how many values were entered, we could do that as well. We have a variable for that. It's called n up at the top there. Set it to 0 to begin, and then as we go through the loop, we increment our counter every time we read a new number. To turn this into a function in which we pass in the array and n, we could do it this way. The array comes in, n comes in as a reference parameter. We have a loop control variable I, and it simply reads data into each element in the array and returns the final value of I as n. Now what if we wanted to calculate the mean? This is something we'll have to do in the next program. We've seen this before. It's a simple summation. We're going to loop through all the values in the array and add them up. So we dealt with the summation formula. Now in this example, we're adding up the sum of 12 sales amounts, one for each month. I goes from 0 to 11. There are 12 months. Each sales amount gets added to the sum. The sum is accumulated over the course of the loop. And then we could calculate the mean simply by dividing by 12. If we turn this into a function, the function is passed the array of sales, and after calculating the mean, returns it. Its return type, you will note, is a double. Now let's talk about standard deviations. A standard deviation is a measure of how spread out data are. For example, between one standard deviation above and below the mean, roughly 68% of the data will lie. Here we have a distribution with three values, 100, 130, and 70. The mean of those is 100, and the differences or deviations between each value and the mean is 0, 30, and negative 30 respectively. The average of those is 0, however. So let's try something. Let's square each of those deviations, add those up, and come up with a sum of the squared deviations. When we find the average and take the square root, we get the standard deviation. This is the formula. It's the sum of the squared deviations divided by n. That would be the average squared deviation, sometimes called the variance. For Project 4, we'll use n minus 1 as a divisor, because that's what you would normally use if you had a subset of a population that you were sampling. And in our case, we're looking at housing values, and that would be a subset. So what's our algorithm? Use a loop to calculate the sum of the square deviations. Divide by n minus 1, take the square root, return the result. That's the standard deviation. So what have we learned so far? We've gone through a description of the project, we've gone through data files and arrays, a little review, and we've talked about standard deviations. You may need to review standard deviations more. Pause this video, and that should help. Thanks for watching, and good luck on Project 4.